In this example, we're looking at the combustion of propane again. Okay, we've looked at this in the previous set of slides. When we combust propane, that means that we take this hydrocarbon, in this case propane, and react it with oxygen. So that's indicative of a combustion reaction, that it reacts with oxygen. Okay. Another thing too, though, is that if you are combusting a hydrocarbon, like propane, you're going to produce the two products, carbon dioxide and water vapor. Okay. So here, I need to make sure that my equation is balanced, and it is not. Okay. I see that I've got 3 carbons here and only 1 carbon on my product side. So I'm going to go ahead and shoot for putting a 3 there. Okay. So now I've got 3 carbons and 3 carbons. I have 8 hydrogens in my reactant side and only 2 in my products. So I'm going to multiply that 2 by 4, so now I have 8 hydrogens. All right. Now what I can do is I can look at my oxygens. I've got 4 times 1 plus 3 times 2. So I've got 6 plus 4 is 10. And over here I only have got 2. So I'm going to go ahead and put a 5 coefficient in the front so that I've got a total of 10 oxygens. Okay. All right. So here we want to know how many moles of carbon dioxide are produced. So we're looking for moles of carbon dioxide when 10 moles of propane are burned in excess oxygen in a gas grill. And we'll actually talk about what this means in the next set of slides. Okay, look for my number unit substance. So 10 moles of propane. So this is what I know. Okay, and it's asking me to find how many moles of carbon dioxide. So I'm looking for moles of carbon dioxide. Okay. So I'm going to start with what I know. 10 moles of propane, which is that C3H8. Okay. All right, and I don't want to talk about moles of propane anymore. So I'm going to go ahead and set up a dimensional analysis problem. Because I'm trying to get out of moles of propane, I will put moles of propane on the bottom, or in the denominator. Okay, and that way I see that my moles of propane cancel. Alright, from moles of propane, I could either find mass or particles of propane, or, since I'm asked to find carbon dioxide, I can use the moles of propane in my chemical reaction compared to the moles of carbon dioxide that they should produce to be able to convert between substances. So I'm going to set up a mole ratio again. So moles of propane on bottom so that they cancel. And in my numerator, I need to have moles of carbon dioxide because that's the substance that I'm asked to find. All right, if I use my balanced chemical equation, I can see that 1 mole of propane will produce 3 moles of carbon dioxide. All right. I see that I'm left with the units that I've been asked to find. So I'm going to go ahead and put moles of carbon dioxide out to the side so that way I do not forget that in my answer. And now I can just do the math. So if 1 mole of propane makes 3 moles of carbon dioxide, 10 moles of propane should make 3 times as much. So I can do 10 times 3 divided by 1. It's just 10 times 3. So I should produce 30 moles of carbon dioxide. And that's it.